All right, welcome everyone. Today we're going to go ahead and talk about Git and GitHub. These are going to be our version control tools, and we're going to talk about their differences and why they are important for us. So we'll start by breaking down Git, and then we'll end our lecture by talking about GitHub. So in part two of our lecture, we'll mainly just concentrate about the tool Git, which works inside of our local machine. So we'll just say lives inside of local machine, meaning every version of Git is unique to everyone's machine. All right. Now, a quick demonstration of GitHub and why this is important. For example, yesterday when we covered the install fast information, we were able to push it all up to GitHub. The entire purpose of GitHub is try to keep somewhat of a version control of everything that we make. Um, if I go back here into a separate demos and notes, so for example, here's Zulu demos and notes, I can actually take a look at the history of all the commits that have been made, everything that was taught, everything that got pushed up. You can see that there's a serial number that belongs to each commit. I can actually take a look at what the code base looked like at this point in history. So in March 8th, when this commit was pushed up 3 months ago, demos and notes this repository looked like this, right? It was still growing. We're still building it as lectures were being taught. You can see that there's commit messages going on there, a bunch of terminology that we don't necessarily know just yet, but it's important as a demonstration to understand that this is going to be essentially our living memory card, right? Just like when we played video games back in the good old days, when you had a PlayStation 1, you had a nice memory card slot. You had to place it in there. You didn't want to overwrite anything that you did in the past, and you just kept occupying more and more card slots, or maybe you wanted to delete the one before. This is essentially our living history of our entire repository from the moment it was created. You can see that it goes all the way into having next pages, and it can show us all of the way back to our very initial commit, which was created by Adam back in February 3rd. Right, so this is the important goal to have here. We want to make sure that we have a clear commit history when we're developing and something that allows us to work together. As you can see, Adam is the one that made this commit, but in between Adam making commits, so was I, adding information to this GitHub repository as we were both collaborating and making sure that this project existed inside of GitHub. All right, so let's start talking a little bit about Git. Yesterday, when we talked about Brew, we actually went and installed Git. Let me actually go ahead and open up a page here that I had from yesterday. There you go. This may look a little bit different for you WSL users, but yesterday we dove into why we conducted InstallFest. Right, we have Brew, which was managing all of our information here for actually being able to install. Oh, hello. Install everything that we needed for our machine and development processes to run appropriately. But we never talked about Git and GitHub. So inside of our local machine, here in this nice little square, we also have Git that we installed that lives as a tool inside of our machine. Now we did install something called GH, but GH is something completely different that we're not necessarily going to interact with too much. So we're just going to concentrate around the concept of Git for this morning. Now, Git is a version control tool that is utilized to keep track of changes within files and directories. It doesn't copy your entire project, but instead, it actually takes directions of what has changed within your project. So it writes down directions of what has changed within the project. Now, these directions can be unstaged. They can be staged, and they can be committed. All right, so those are the three stages of these directions. So we're going to break down how this works here shortly. I'm actually going to copy this down, and I'm going to bring it over here so that we can talk about it more in depth. All right, so here's the grand scheme of things. We were able to install Brew. Brew makes sure that all of our tools or all the things that we're installing are up to date by running Brew Doctor. We're able to install Python, Node, our relational database management, and then we have Git as well. Now being installed. Well, today we're going to break down Git and really get to Git, right? That's going to be the pun of the day. All right. So here's how Git works. When I create a project, and let me actually create a brand new project here. Let me break this down so that we have our drawing in that other location. Currently, this project does not have a Git repository keeping track of it. So we have a new project. Inside of my project, I can go ahead and create a couple of directories and say I do something like, let's just call it server, and I make a directory named client, right? And in my server, I start writing something in Python. Then I have a JS script inside of my client. Well, as of right now, the way my project looks is it has two directories inside of it. One named server and one named client, each with their own independent scripts. What can I use for a script? Let's keep it with circles. All right. So this is currently what my project structure looks like. Nothing necessarily too crazy or nothing of concern as of now. But if I wanted to share this code with anybody, or I wanted to develop this code as an actual developer and have good proper practice, I would want to utilize some sort of version control so that as I create my project, this information is being updated in a live version, right? Or it's being kept track of correctly. So I need some sort of chain that will have memories where each memory, and this is going to look like a familiar data structure later on, where each memory has some sort of message. Maybe this is my initial memory or my initial spot. I just started my game, right? I just started my project. Then later on, maybe I do something like add a function to py. Then as this is continually growing, maybe I want to create some sort of feature branch. And in this branch that lives outside of my main storyline, I want to experiment and refactor my Python function. Then here I can go ahead and add a function to JavaScript. Once my function is refined, well, I can then merge it. And have a new location in memory where both my JavaScript information and my Python project have been updated. So functions or complete functions. This is going to be somewhat the goal here, right? I want to make sure that I'm able to create a version control or a living history for my project that keeps track of my project as it's changing in different stages. We're not going to go in too much in depth as to how Git does this just yet. We'll go ahead and talk about how Git does this and everything that's happening behind the hood in regards to Git and GitHub later on when we start breaking down our Git and GitHub workshop. We have an entire Git workshop where we talk about Git for, I believe, 4 hours for 2 days. So that's when we'll actually break down everything that's happening behind the scenes. But for now, what we want to do is we want to make sure we understand the surface level of the tool and that we're able to utilize the tool within our project. So here we go. We have our client, we have main.js, and we have our server. Again, as of now, there's nothing in memory that's keeping track of this project. Well, in order to start the process of being able to understand or being able to keep track of my project as I'm creating it, is by creating a Git directory. If I run ls-a now, you'll see in my terminal that all I have is a client and a server. There's this dot dot and this dot directories, but as we covered yesterday, those are just essentially a memory space of how to go back and how to reference this current directory. Now, if I want to change this so that I'm keeping track of my project, I need to run the command git. Actually, let's run git first and see what that just brings back to my terminal. If I run git, you'll see that it gives me a suggestion for all of the commands that I can utilize. And this is helpful to an extent, especially when we're first starting to utilize GitHub. But you will notice that directions and commands start becoming a little bit confusing the further and the fancier you need to get with it. So we'll start talking about different commands here later on. All right. So now I ran Git and I got this information back. So since I want to initialize a project with Git, all I need to run is git init. And here it tells me, hey, we have created a new Git repository, and here's the current location. So essentially what just happened is I created now a .git repo that lives inside of my new project. And what this .git repo is going to do is it's essentially going to keep an eyeball. Oh, can I draw an eyeball? Let's see. Challenge. Essentially going to keep an eye on everything going on within the project. All right, so .get now knows that it needs to watch everything going on within the project. Even if I create something new, it's just going to go ahead and say, oh, something new was created, and now we need to keep track of that as well. All right, I saw a hand being raised. Unfortunately, I don't remember who that was. Was that Nick by any chance?
Y- Just to verify, when you run the git init, you do it in the highest level directory because it won't look at anything above that directory, correct? It's just down from there.
That's correct. So if
Okay.
I would have done it inside of the server directory, then this eyeball and this .get directory here would live inside of the server. But because I did it in the new project directory, that's how it keeps track of both of those. Right? So you want to start it at the parent, not the child. And let me break that down. Go ahead, Andy.
Um, so you said you ran the git init in the new project while you were in that directory. Is that what you're saying?
That's correct. While I was
Okay.
inside of the new directory, that's where I ran the .get in it.
Okay. Could you tell me like what would be the difference if you ran it inside the server or the client?
Absolutely. Yeah, let me break that down here. Da-da-da. All right. Awesome. So if I were to run the .get init command at the new project level, what would happen is my get init repository starts existing. Actually, I'm just going to take that eyeball that I created earlier. That's what we do. All right, there you go. All right, because I created or because I ran get init at the new project level, get init is going to keep track of everything that is a child of the new project. All right. If I would have ran it inside of the client level, then what would have happened is it would have kept track of everything that only belongs to the client, but it would not keep track of everything that's inside of the server directory. It's only keeping track of children of the parent directory where we ran that git command or where it's being initiated. If I would have ran it inside a server, then the only thing it would have kept track of would have been main.py and anything that happens within server. So that's the importance of where you run that .get command because, or excuse me, where you run that get init command. So because we ran it at the new project level, it's keeping track of both my client and my server directories because they're both children of the new project. Does that answer your question, Andy?
Yeah, it answers my question, but what would be the disadvantage of just constantly running it at the highest level?
So the disadvantage of constantly running at the highest level, and this is getting a little bit more into a systems design process, right? If you're consistently running at the highest level, what you can run into is multiple different merge conflicts. You could grow your project a little bit outside of scope to where changes may not be isolated as much as they need to be. Currently, right now, what we have is a very simple directory structure. But if we were actually working inside of a full stack environment, your client may just be pages upon pages upon pages of JavaScript files, HTML documentation, extensive libraries, API calls, uh, multiple tools that you just maybe want to isolate to only belong to the client. And same thing with the server, right? As the server is being rendered, some of it may be working within WSGI, some of it may be working as an asynchronous functions, um, a bunch of terminology that we probably don't know yet, but that we will hear later on. The point that I'm trying to get to is these two client and server directories are going to become massive. They're going to have a ridiculous amount of information inside each one of them. So typically, what ends up happening inside of actual software companies is they make a .get directory that keeps track of only their client side and their client side UI, and then they have a separate directory and repository that only keeps track of their server side. That way they can ensure that anything that changes with the server is tracked with the only history that pertains to the server. It's kind of like an isolation of information, just like with the client. We only want the changes that happen to the client to be tracked by that repository. So we isolate that information by only creating that at the client level. But then at that point, we would have two separate Git histories, two separate memory cards, keeping track of two chains of memory. Does that answer your question, Andy? I see the thumbs up. Awesome. All right. Any other questions? Okay, great. So now we talked about Git init, and we understand that when we create this .git init or this .git repository, what it starts doing is it starts keeping an eyeball on all of the children that live within the new project. Well, what do we mean by that? By keeping an eyeball? How do we get to this portion of actually building this chain of memory? Well, this is where the three stages come in. We have unstaged, staged, and committed. So let's go ahead and build out our three stages. We have unstaged. We have staged, which I believe this one will show up in green. And then we have our committed, which once it's committed, it will fall inside of just the regular spectrum. So it would become a black square. All right, back to regular code, solidified in history. All right, let's run git status here. When I run git status, what it's going to tell me is it's going to tell me, hey, these files and directories are currently not staged or they are being untracked. They're unstaged files. So it's telling me that both my client and server currently right now are living within my unstaged portion of Git. Now, how do I actually start adding information into the stage portion? There's a couple of different commands. And it tells me here you can even go all the way to just not only adding file, but you can specify the entire directory if you'd like. So you can say, hey, well, in this case, I would like to add my entire client directory. Let me go ahead and clear my terminal here. Run git status one more time so we can see that output. So there's that output saying that client and server are not in. I can run git add and then specify client. And now when I run git status, we can see that client and main.js are now staged files that are ready to be committed. So I made some changes to the client. Hey, I know this is ready to go. So now I can go ahead and put it in the staging directory. No longer lives inside of unstaged. Well, I actually never made any changes just yet. I want to make that initial space in memory. So now let's go ahead and add my server separately. I'm going to run git add server, run git status, and now both live within my stage directory. Awesome. So now that both of them are staged, I can go ahead and make my initial commit. So I'm going to run git commit, and I'm going to add this -m. This stands for message. And then in single quotation marks, I'm going to add the message that I would like to be to identify this commit by. In this case, the commit that I would like to identify it is by init. And then here we're going to get a message. We're going to say, hey, git commit -m init. Here we can see main root commit. It gives me a hash, tells me the message, which is initial. Two files have changed. There's 0 insertions, and the two files that have changed is a server and client directory, main.js and main.py. So now both of these have now entered the committed portion of my directory, or excuse me, of Git. Now that they have been committed, what essentially happens is this commit lives. This commit now lives inside of this .init commit portion of my history. Once it was committed, it was added into my memory space, and that is the current version of my project. All right, Dallas, let's hear it.
Is this all still just on the Git side, not GitHub at all?
Yes, that's correct. This is all only happened
Okay.
inside of the Git side.
And I follow up to that. So I've used GitHub in the normal user sense a bit, but I haven't used Git, or I don't know if I have used Git. So I don't have any visual representation of this in experience. But do we normally see anything like we see on GitHub with all the files laid out like that? Do we interact with Git in that kind of way locally?
Yeah, that's a great question. And we're going to see that here shortly. We're going to actually connect it to during part 2 of our lecture. And that's where we're actually get more of the visual as to where we can actually see files. Inside of your terminal, what you'll see is a log history, which I'm about to cover right now. Does that answer your question?
Yes, sir.
Awesome. All right. So now, just to do a quick recap, git init. When we ran git init, we created a .git directory at the new project, which is our parent directory, because it is a parent of server and client. Git will keep track of both server and client, or anything that gets created at the new project level. From there, we found out that Git actually has 3 stages. It has an unstaged area, a staged area, where I can move files back and forth with, and we'll go into that here shortly. And then we have the committed. When we go and create a commit, that commit gets saved into history or into memory under a message. The message that I had was init. And I added this I added that commit of the files that have been committed inside of that memory space. Does anyone have any questions over the information that we have covered up to this point? Let's hear it, Andy.
Could you please elaborate again? I don't know. I think like I kind of understood it when the last thing you said about the memory space committed. If you could just go over again one more time.
Yeah, absolutely. So we had these files that we made sure moved from the unstaged portion all the way over to the committed portion. Now, when I ran the command, and it might be easier if I also write this down as I'm talking about it. Oh, that will do it. So here we have the get init command, which created a Git repository that keeps track of all children directories and files. By running git add, or excuse me, git status, we can see the current stage of all living or all files. And the three stages were untracked, tracked, and committed. Git add, and then file name, or directory name, moves files or directories from untracked to tracked stage. Once we have files that are staged and we're ready to commit them, we can commit them or generate a memory space by saying git commit -m message for memory, which creates a memory space within Git that captures the current stage or the current stage of our project. All right, that's what we've covered up to this point. When I ran this git commit -m, all I did was I created a memory space named init because that was the message that I had. And all those directories and files, their current stage, which is just empty directories and files, because my files don't have any content, were saved inside of memory. And essentially, I took a screenshot of my project and I put it inside of this init message. Did that help at all, Andy?
Yeah, it helped. Just one more question about the adding. So git add, if you have same file name under two different uh let's say client server, right? Under client and server, you have same file name. Would that be an issue when adding? Like you don't want to change main.js in client, but you want to change it in server or vice versa. How would that affect it?
Yeah, so when it comes to that, you could just specify the path to it. So for example, if we had, let's say, a README in both of these, and I wanted to run that get commit message, all I would do is I would specify which one of these two files, or when I run it, this get command would respond as to which directory I'm currently in. So if I was inside of the server directory, I run get add readme, then it would only add the readme inside of the server directory. But if I am at the new project level and then I add it, I would have to specify the path. And oh, hello. The way I would do that is I would just simply say, hey, I want to add a specific file. I'm going to git add server slash readme.md. And then it would only add the readme inside of the server, not the one inside of the client. Does that answer your question, Andy?
Yeah, it answered my question. What I was wondering uh if you're rushing and if you don't properly annotate where you want this thing to be added, and you just do README, what would that just change README to all of the directories?
No, this would throw an error instead,
Okay.
because what it would try to do is it would tell you that this file doesn't exist where you're trying to reference it. So you would have to specify the path to where you're going. Otherwise, it would throw an error for you. If you're doing
Okay.
a file at a time, it expects one file at a time. Awesome. Carlos?
All right, this should be pretty quick, I hope. When you're doing the commit, the git commit dash m, do you need the single quote for the message, or can you do it without the single quote?
You could do single quote for the message. Yes,
Got it. Thank you.
of course. All right. Well, let's go back here and let's continue looking at our Git history now. Now, if I wanted to see what this memory looks like currently right now, I can run something like git log. And when I run git log, it tells me, hey, the user, Favela08, on Tuesday, June 3rd at 7 o'clock in the morning or 7:36 in the morning, 2025, there was a commit that was created. This is the serial number for the commit or for this spot in memory. And then my message saying, hey, the message here was in it. Now, why is the message important? This serial number is completely useless. It doesn't really tell me what happened inside of this message or this commit. So when you go to create your commit messages, you want to make sure that they specify what the commit is accomplishing. So for example, you'll see that all of these are speaking more in like a present tense, right? They're saying add a function to py, not created a function to py. It's this commit, when established in memory, what it accomplished is added a function to the py file. So let's go into creating this next commit there. So I have my client, I have my server. If I run git status, you'll see, hey, there's nothing to commit. Your working tree is clean. That's saying that nothing has changed. Everything is still living within the committed from the last portion or the last place where we moved anything. So there's nothing inside of unstaged or staged. Everything is nice and clean for my working tree. Well, let's change that. I'm going to go ahead and go into main.py, and I'm going to add a function. Let's say hello. And all this function is going to do is say hello. Not a crazy function. You'll notice that main.py is now in yellow and that there is an M saying modified. You also notice these two little lines here. What these lines actually, excuse me, everyone. What these lines actually represent is that these are changed lines. There has been a change from the previous stage of my main.py file that was not part of my so my previous stage was where this was empty, and I have now written text. So the text has been inserted into line 1. A new line was created, not in line 2, and text was added into line 2. All right. Well, now what's going to happen when I run git status?
It's going to pick up on that and say it's modified.
Yeah, it's going to tell me something is unstaged, right? Something has changed now. So there is an unstaged file in existence. If I run git status down below, you'll see modified server main.py, and we can see that it is untracked, and it tells me you have to add this if you want to commit it. So now my server lives in the unstaged portion. Well, let's go ahead and do git add again, and I want to add server slash main.py. Now let's run git status. Now server is now staged. Well, let's say that I'm not ready, right? I added it, but I decided, you know what? I want to change a couple of other things here. I'm not necessarily ready to continue moving forward with this portion of having something staged. Maybe I want to put it back into the unstaged file. Well, it gives me a pretty clear example of how to do that. It actually tells me here, it says, hey, in case you're not ready and you did not mean to do this, you can get restore dash dash stage and specify the file to unstage it. Okay, well, as of right now, server slash main.py is inside of my staged portion. I'm going to move it back one. I'm going to say get restore dash dash staged and then specify the file server main.py. Now, if I run git status one more time, you'll see, hey, main.py is back into the unstage. Instead of just saying hello, I want to say hello, Avenger. This is instance code. That's it. I just wanted to add that to print statement to my function. All right. Now I'm ready to actually stage it because I actually want to commit this into memory. Well, now I can git add again, server main.py. If I run git status, you'll see that server main.py is now in the staged portion. And now I'm ready to commit. Well, I can commit by running git commit -m, add a function to py. You can see that a new commit was created. And now this commit message has all of the changes that happened to that server directory. All right, now to close the loop, let's take a look at what happened to our Git history now. If I run git log, I can see that git log has add a function, which is the newest stage that I'm currently in. And then before that, there's my init commit message. All right, I see a couple of hands up, so let's go ahead and take a pause and address questions. Go ahead, Carlos.
All right, so let's say you stage that the main.py,
Mhm.
but you wanted to make a change to it. Do you necessarily have to bring it back to unstage, or do you have to unstage it, make the change, and then stage it again? Or can you do while it's staged, can you make the correction and then like how would that work?
You can definitely leave it while it's staged and make a new change to it. What happens under the hood is every time something moves between this unstaged and stage portion, a screenshot of directions is taken. So to avoid overloading or to avoid messing up, pretty much just causing misbehavior to happen in between these stages, it's giving you the option of saying, hey, if I'm not ready, or this isn't something that I actually want to take a screenshot of directions of, let's move it back, right? Because otherwise, I moved it to server, then I made some changes again, right? Well, when I make those changes again, it puts it back at unstaged, but it puts it in this like weird OODA loop where half of the file is unstaged and half of it is staged. And it can just, it will just make a mess. So it's better the moment that you put it in the stage, commit it, then make your changes. Or if you want to make more changes, unstage it, change the file, and then put it back inside of stage. Does that answer your question, Carlos?
Yes, sir, it does. Thank you.
Awesome. I saw a couple of other hands up, but they have disappeared. If you had a question, I'm gonna ask you to raise your hand again, unless I already addressed it.
I had the same question.
Okay, perfect. Okay, fantastic. So now here's where we're at inside of our memory space. But now we have something called a feature branch. This branch out here that I'm about to create is going to live outside of my actual history. Now, this is where things can get a little bit confusing. I'm going to concentrate on this refactor py function. I'm going to actually run a command named get branch. And what this command does is it shows me the different branches that exist. Currently, I have a branch. Oh, hello. That is referenced to as main. This is my main branch. And is where all of my final code is going to live. Now here is a feature branch. And what this feature is going to be is a function refactor. All right, that's the entire purpose of this branch. Well, how do I create it? The easiest way to create a branch and actually check it out is going to be get checkout -b and then the name of the branch. And then we'll break down this command here. So get checkout is utilized to switch in between branches. And this -b is a flag saying, hey, this branch doesn't exist, but I want you to create it for me. And I'm going to create it as func refactor. And then I get a message telling me, hey, we have successfully switched to a new branch called func refactor. Well, now let's go ahead and run this get branch command one more time. You'll see that get branch still exists, or excuse me, that get branch still returns the same output. I still have main, but main is no longer green and it doesn't have this asterisk on the side of it. Instead, there's now a new branch named func refactor that is currently green and has that asterisk. That's letting me know that the branch I'm currently working in is a func refactor branch. All right. Excuse me, everyone. There's an alarm clock going off. I apologize. Well, now, if I want to change back into main, actually, I'm going to turn that off because I'm pretty sure you guys are hearing that in audio. So I apologize, everyone. Give me a quick second here. Okay, perfect. So now you'll see that I'm actually inside of this function refactor branch. If I want to go back to main, I can just say get checkout main. And that sends me back into my main branch. Okay, well, what's the point of these branches? What's the difference? Because as of now, all of my files and folder structures still look exactly the same. Well, let's see what happens when we make some changes into a file. So I'm going to get checkout my func refactor. Well, now in my func refactor, I'm going to change this function here. Currently, this function is printing something, but I actually want it to return information. And instead of saying hello, maybe I want to say, hey, I want this function to be called greet Avenger. And what I want this function to do is I'm just going to simply have it returning string. All right, just a little bit of extra oomph inside of this function. That way, whenever it's being referenced, I know that this function will always return string. Well, as far as the surface level of what's going on within Git, nothing has really changed. My server and my client are still living within the last commit. Now that I made some changes into this main.py, server is going to live in the unstaged file. So when I run git status, I expect to see what?
That
So
server is going to be in the unstaged for the refactor branch.
Yeah, so if I run git status, we can see, hey, server has not been staged. I can simply add that. So git add. And instead of having to specify one file at a time, I'm just going to put a period. Now that period stands for all unstaged files. I can automatically add them into the stage portion instead of doing one file at a time. So there you go. Now we're going to run git status. I see that the server directory is now inside of staged, and I can finally commit it. And the commit message that we wanted here was refactor py-func. So I'm going to say git commit -m refactor py-func. All right. Give me a second, Justin. I will get there. All right. So now this commit that we created only exists within this refactor py-func. Well, let's see the difference now, because there's got to be a reason why I created these two branches, right? If I run git log, notice that it tells me, hey, you're inside of func refactor. Only inside of func refactor is there a message refactor py-func. The previous state in memory comes from the branch main, and that's my add a function. And if I continue moving down, the one before that was my init commit. Right? Pretty much what I expected to see there. If I follow this daisy chain going backwards, all right, my refactor py-func goes there. Okay, everything adds up. All right. Well, now let me go ahead and check out main. And pay attention to this file when I run this command. So when I check out main, we're going to see all of this code completely change to its previous stage. So now we're back to function say hello, where it's printing information instead of returning information as a function. And if I run git log here, you'll see that the log is only returning information pertaining to main. All right. So currently, I am here. And as I switch back and forth in between those two in between those two branches, so get checkout, func refactor. If I run git log again, now head, or excuse me, the current feature that I'm looking at is inside of func refactor. All right. At some point, somebody raised a hand. I apologize. What was the question?
Yeah, so you use the git add period, and I was wondering if there was or what the difference between that one and like git add with a wildcard at the end would be, like git add star and git add period.
Got it. So, let me see. Let me add that in here. So the command git add period will add all unstaged files into the stage.
And is that just in the current directory that you're in? Or
That's
will it do like subdirectories as well?
that's everything that's inside of unstaged. So whether it's inside of subdirectories, so currently the way we were working on it, when I ran that command, I ran it at the new project level. But if I were inside of server and there were unstaged files both in client and server, and I run git add all, it would do it for both client and server. Anything that is unstaged will automatically get added.
And that's if you're doing it from server, it will do everything that's unstaged. Okay.
Awesome. Any other questions?
Yes, the other one was if you used instead of a period, you used like a wildcard symbol, like the star.
I'm not familiar with using it with anything else. I believe only the
I
period.
just thought that it would be used. Never mind then.
Yeah, absolutely. All right. Michael?
Just to go back to where you're staging, if it gets everything, the dot method gets everything.
Mhm.
That only works if the eyeball is on the larger stage. That's correct.
That's correct.
So like in that picture, you have two different gets. That wouldn't look at the other one, right?
Correct. So currently right now, what we have is this.
Okay.
All right. Dallas?
For the dot that you're putting after add, git add dot. So that was for like the terminology where it's everything in that directory, all the files, right? That you're adding to it.
It's everything that's unstaged.
That is unstaged, and does that delve into the other directories that are within that directory, or only within that spot?
Yeah, so currently, right, that changes. If I would have made changes inside of both main.py and main.js, and I execute the command at this location, I say, hey, I want to git add all. It wouldn't just add this main.js. It would actually go back and say, hey, everything that's unstaged that is being tracked by Git, so both main.py and main.js are unstaged. Everything that is unstaged will get added, right? So it's in reference of anything that belongs to the parent.
Okay, got it.
Awesome. All right. Any other questions? Oop, there it is. Okay, awesome. So now we have our two feature branches. Let's go back into main and actually make a new commit. And this time we're going to actually make some changes to that JS file. So I'm going to run get branch just to see what branch I'm currently in. I'm currently in the function refactor. I'm going to get check out main, which is what allows me to switch branches. Let me add that here. All right. So now I'm back in main, and inside of main, I'm going to make a change to main.js. Here, I'm just going to add a function. Going to keep it simple and say hello again. And this function is just simply going to console.log hello Avenger. All right. So now if I run git status, we'll see that client is now what lives inside of that unstaged file. I'm going to go ahead and add it. If I run git status again, you'll see that client is now inside of staged. And I'm going to commit it. So git commit -m add a func to JS. Great. So now that client commit has been generated. I bring it down. And there's my commit message. All right. Now again, if I run git log, we had add a function to JS. And then the previous to add a function to JS is add a function to PY. Awesome. If I get checkout refactor, or excuse me, func refactor, main.js is empty. And if I run git log, you'll see that my newest commit message is refactor my py func. So now I have two separate histories. They haven't merged yet. As of now, my func refactor has the following history that moves in this orientation there. And it was in gold. Let's do extra large. All right. And my main currently just has this orientation when it comes to memory. All right, so now we have two separate files living from one another. The breaking point being add a function to Python. All right. Now this is allowing two people to make work inside of the same project. Now there's one person making changes to the JavaScript function. There's one person making changes to the Python function. But in the end, we want to make sure that all of our work is together. So I want to bring it all in and complete my functions. Well, how could I do that? Now, typically, the standard, you do not merge your feature branch straight into the main branch. You may run into a considerable amount of conflicts, so you don't want to do that. Instead, what you want to do is you want to merge the main branch into your feature branch, and once that's successful, merge your feature branch back into main. So it's kind of like a sandwich effect here. What we're going to do is we're going to grab our feature branch and merge it into func. And then we'll grab func and merge it back into main. This will allow main to continue living as if nothing ever changed. All right, so this is our end state here. Well, again, what branch am I in? Let's go ahead and say git branch. I'm currently inside of that func refactor branch. I want to bring this information in. So I'm going to git merge main. And there it tells me, all right, well, we're merging into main. Please enter a commit message to explain why this merge is necessary, especially if it merges updated upstream. So here it tells me, all right, you're merging something, but we need to know why you're merging it. And this is where this last commit message is being imported. By merging, I am creating a commit. Even though I didn't do git commit -m, or even though I didn't go through the entire process of doing git add and then git commit, I am still creating a new set of directions, a new commit saying, hey, these two branches will now live together. All right. Now what this sends me in is into something called the Vim. We're not going to go too far into how this works, but we are going to talk about how we can actually interact with Vim. So here in my terminal, if I go ahead and click random things on my keyboard, they're not going to actually respond. I have to press I to enter insert mode. All right, so I clicked I on my keyboard, and that allowed me to enter insert mode. And this actually allows me to write code or write into this file. What I want to write is complete funcs, because that's the message that I want to have. And I'm going to add an ampersand, or it's not an ampersand, and I really got to figure out what that's called before we continue classes. All right.
Hashtag.
Not a hashtag. I know it's
Tic-tac-toe
Pound
board.
side.
Ogle
Pound.
fort.
Pound hash.
There it is. It's a pound. Thank you.
Guess no one likes Oglethorpe.
All right. So now this pound is going to be like a comment for this line, saying, hey, these lines here are just comments. Do not take this as a message or part of my message. Instead, complete funcs is the only thing that I want you to take in as a message. All right. Well, I'm done writing in this file. How do I exit and how do I save? Well, I clicked I to enter insert mode. So you might think, well, maybe if I press Q, that will quit insert mode. And unfortunately, that's not how it works. Actually, you have to click escape on your keyboard, and that will exit insert mode. So now we're done interacting with the file. But to actually save it, we're going to place a colon, which tells Vim, hey, what I'm about to give you is a command. And the command that I wanted to have is write and quit. So WQ. And when I run this, it is successful. All right. So now everything has been inserted. There was no merge conflicts. You'll notice that the current branch that I'm in is still func refactor. But even though I'm inside of func refactor, I also have this main.js branch. That's because my current head now lives here. I have officially merged both of these information. You'll see that my refactored Python function is still living. My main.js function is still living, and everything was merged. If I run a get log shows me this complete functions. It shows me the add function to JavaScript, and it also shows me the refactor, my Python function. Right? By merging my histories, what I did is I essentially inserted this linked or this node to highlight that. And I inserted it back into the regular flow of time. It's just not actually in there. It just merges it and makes it seem like it's in there. All right. So we had our own separate branch. We merged it. And by merging it, I reinserted this back into the natural timeline flow. All right. Well, let's take a look at main now. Here's main.py. I'm going to get checkout main. Well, if I go back to main, main still loses that information. Well, that's because main doesn't have the merge. If I run get log, you'll see that there is no merge message. That was never processed by main. So now I have to merge the feature branch. Get merge, func, refactor. And that brings it back into main. So now both main and my func refactor branches are up to date and live as one single stream of memory. All right. Let's open it up for questions because I know there's questions. That's confusing. Dallas, hit it.
Yep. So the last command that you just did a few seconds ago, was that the gold line on the far right there?
Yeah.
Was that just you just did that the other part before where you're still on the func refactor branch and we're doing the complete functions notation there with the insert. Was that before that big gold line? Was that still in the purple?
Yeah, so that was in the purple line, right? So
Okay.
merged into the func refactor, which is the purple line. That's how we merge main into this func refactor. And then we merged it back into main. And that was the goal.
I'll probably need to just rewatch that and study it.
All right, awesome. Alex?
Yeah, so at this point, even though you've merged from main to refactor and from refactor to main, they're and they both reflect the same history and everything. There's still two separate branches. Okay.
Yes, that's correct. All right, Chase. I think you're muted on your headset.
So in practice, you would make
That's some sort of audio filter, brother, and you're coming in with a really high pitched voice.
Helium sound there.
one second.
All right, I'm gonna Daniel go for it, and then we'll come back to Chase.
So when you were merging from the basically taking the main branch and merging in the function branch, I noticed that you didn't have to like put in a new name for like what you were doing. Is that just because you didn't add anything to the function branch after you merged it with the main branch? Basically, like when you went down with the purple line on the right hand side, you had to put in what you were doing, like what it was. You were putting in that as a complete function. But when you went back up with the gold line, you didn't have to annotate a name with it. And I
Yeah,
was just wondering if that was because you didn't add anything, or if you did add anything, would you have to then annotate what you were doing?
that's a great question. So if I would have changed anything else in main and then re-added it and remerged it, then it would have asked me it would have prompted me again of, hey, you need some sort of message. Like there's two different histories. But at the point that this purple line happened, that I merged, and I guess there would be a better representation if I drew it here, right? The moment that I merged it and it asked me to have that message saying, hey, why are you merging? At that point, both main and Funk Refactor started sharing the same history, which made them compatible to one another, right? So first they weren't, which is why it asked me to write a message saying, why are you doing this? And once that message was completed and the commit was created, now they're compatible. And because they were compatible, when I merged that Funk Refactor back into main, it didn't really care. I said, oh, well, these two are compatible, so I don't really need any of your input. Let's just keep moving forward and I'll merge it for you. Does that answer your question, Dan?
Yes. So basically, if you were to have added anything else into that Funk refactor branch after you merged it, it then would have then showed a conflict, and then you'd have had to. It would no longer be compatible. Is basically what I'm saying. All
Exactly.
right. Thank you.
Of course.
Excuse me, can I cut in there and add to that question?
Yeah, go ahead.
Uh, so since the main branch was already, it's not added to when you use the what you just said with the gold line. You're not adding to the main branch with your Funk Refactor going towards the main branch with the gold line. So what are you accomplishing at that stage?
Got it. So what am I accomplishing? So essentially everything when it comes down to it and looking at bigger picture further down the road, I'm working with multiple people, right? Or maybe I'm even working with myself, but I want to make sure that I'm protecting my main branch because that's where like my golden work lives. That's where my what's going to give me an A on the assessment or what I know for a fact is something that I want to deploy. It lives. I want to protect that main branch at all costs, right? Because I don't want to accidentally break it. And then now I don't have anything to present, to submit for my assessment. I don't have anything to actually upload into a deployment branch and actually deploy so that I can show it as my portfolio project. So instead, I make all of my development inside of different feature branches, right? And once I merge it, if I wanted to add a new feature, maybe I wanted to write some other script instead of JavaScript, I wanted to write it in TypeScript. Well, I would do some sort of new feature branch. I would break up again. I would have a series of commits that live on the outside. And then eventually I would merge it back with main once those features are completed to allow main to just stay nice and clean and live forward without having any sort of broken code inside of it. Does that answer your question, Dallas?
No, but it may be because I misunderstood something else. So I get the main idea that you just expressed again, where we have something outside so we don't save over the main part. But I thought how it was said for the gold line that we saved from the main to the function, and we basically just saved the exact same thing back to main without making a change. I didn't get that part.
Oh, got it. Okay. Yes. So you mean how the purple made all the changes to make main live inside of func refactor, but then the gold, like what was the point of merging this portion back into main?
Yeah, is it merging anything?
Yeah, got it. Okay. So when we merge everything, everything only lives inside of that func refactor. When we merge at this purple line here, all of the actual merge code only lived inside of the func refactor. I understand that. So I think I made the common misconception when I was first learning it, where I thought merge meant that both of them were tracking, right? I would assume that if I am merging func refactor with main, both of them would reflect one another. That's not the case. When I merge main into func refactor, only func refactor is keeping track of that merge. So in order to have main keep track of the merge as well, I have to merge func refactor back into main. That's the only way that both of them are sharing the exact same history.
And the reason you do that is so you don't break main, correct?
Right.
Okay, I think I get it now.
All right, Andy?
Yeah, so I got a two-part question. Going off of what you said, don't break the main. So that is why there's an order of precedence, or not order of precedence. There is an order that you have to do it. You have to merge main into refactor before you merge refactor into main. Is that what you're saying?
Yes.
You can't go the other way.
You can, but it's not
But it's
recommended.
going to break essentially.
It-
So,
right. It could break. So you don't want that.
okay. And then the second question is, while you're working on your refactor, and when you first made that branch, um, everything from main was included in that branch, correct? In that new branch. So while you were working on the refactor and everything you're working off of based off of the original code of whatever the main was, and the main changes drastically, and your refactor is no longer compatible with the main at all as far as code is. Uh, I guess I do you kind of understand where I'm going with this?
Yes, I do. So what you're referencing to is something called a merge conflict. And what happens is you try to merge two branches together, and what it tells you, hey, these two branches are too different, and I can't just manage an automatic merge for you. You're gonna have to manually tell me how to make this merge happen. I don't have an example here to demonstrate, unfortunately, and I'll try to look for something more complex. That is a rough situation to try to simulate on purpose. If that happens, what it's going to do is it's going to bring up two separate portals. And each one of those portals will have one branch representing main, and then it'll have the other branch representing your refactor. And then after it shows you both of those, what it's going to also have is it's going to have a list of files. And somewhere in between that list of files, it will tell you in red where that merge conflict is coming from. And as you click through those files, it's going to show you what the code is in main and func refactor for each one of them. When you click on the red one, it will have text or some block of code that may not be something relatable to another. So let's say def, say hello, and then all this one does is return hello. And then over here, inside that same block of code, it may just have def say goodbye. Obviously, they would be a little bit more complicated. This is just for demonstration purposes. And this one just says print goodbye. Right? You yourself would have to choose which one of these is going to actually go with. It will have a button at the lower right-hand side of each one of these, and then you'll just click on the button that you want to keep. So if I wanted to keep mains information, I would click on this button and it would reset this file to the color black, and both of these files would reflect the information from main. Does that answer your question?
Yeah, that does. Thank you.
Of course. All right, Cody.
Yeah, I noticed when you're creating the branch, you used a capital B instead of lowercase b. Um, I've messed with branches a little bit and I've used the lowercase b. I read the Git docs and I'm just curious why you used the capital B. Like, is that like a normal flow than the lowercase?
The lowercase b will only create a branch inside of your Git tool. If you do an uppercase b, that branch will also be created inside of GitHub once you link it to a GitHub repository. So
Okay.
lowercase keeps it inside your local machine. Uppercase will ensure it gets reflected both in your local machine and the cloud.
Okay. Okay. Thanks.
Of course. Any other questions?
How's Chase doing?
Oh yeah, Chase.
Do I sound better?
Oh, there it is. Yeah.
Okay. Yeah, I fixed it. I was like, I was hoping I didn't sound like that yesterday too. Damn.
No.
No, we would have smiled way too much.
All right.
You still
No,
have
someone else asked the question that I had. It was just about like in practice going from making all the changes in the feature and then making sure it works in the feature before merging.
Okay,
Yep.
perfect.
Thanks.
All right, everyone. So up to this point, we were able to successfully work with Git. We were able to create a Git directory that would keep track of files. We were able to maneuver set files between unstaged stage and the committed stages of Git. We made commits to have a living history for our project. And we were also able to create a feature branch that we were able to merge back and forth in between main and our feature branch. At this point, does anyone have any questions or anything that I covered over Git? Perfect. If there aren't any questions, we've been going on for quite a bit. So let's take a solid 20-minute break and let's come back at 10:55 to continue on with part 2 of our lecture. Thank you so much, everyone. And I'll see everyone back here shortly. Okay, welcome back, everyone. Before we left for a break, we had just finished speaking about Git, how it works within our local machine, and we even went through the process of actually creating a small project utilizing Git that included a feature branch and so on. Great. Now, again, when we talked about this earlier, we specified that Git lives inside of our machine. But we know that the goal is for things to end up in GitHub. Let me zoom in here. So here's my local machine. My local machine holds my project. What is happening there? All right. My local machine holds my project. And inside of this project, I have my .git directory, which holds records of instructions, of commits, of everything that happened to my project up to this point. All right, there's my records, my log of different commit messages. Well, the goal here isn't just to keep things on my machine. Again, the goal is to be able to share code or to utilize GitHub to even deploy code. We're going to learn more about GitHub and all of its capabilities later on. But today we're going to focus about how we go into actually creating a repository, getting information onto GitHub, and sharing said information with other people. So, for example, if my machine is holding my project, inside of GitHub, there needs to be an equivalent, right? I have a project directory that is holding all of my project information and all of those Git instructions. But inside of GitHub, I don't have that same exact layout. Instead, inside of GitHub, what I have is a repository. And a repository also keeps track of all of these .git. And we're going to talk about that here shortly. So first, let's go into creating a repository. I'm going to come here, go over to my repositories, and I'm going to click on new. I want to create a new repository. I'm going to be the owner, that way I can share it with all of you. And I'm just going to call this the Avenger project. Right, we have this as public. I'm not really going to add a description to it. Now, because I am going to add an existing project, something that has its own Git history, I am not going to add a README file. Again, because I am going to push an existing project, I am not going to add a README file. If you add a README file, it's going to initiate a Git history where the initial commit has the README file already inside of it. Now, what happens when you try to add your project into that is it's going to have conflicting Git histories that are unaligned from one another because their initial commit never matched. So I'm not going to add a README file. I don't have to worry about licenses or a git ignore as of now, so I'm going to go ahead and create my repository. All right, my repository has been created, but it's completely empty. There is nothing there. If I scroll down, we can see that it walks me through the process on how I would add this repository somewhere. Well, if I take a look at TLDraw, I have GitHub here on the far right-hand side, and I have my machine here on the far left-hand side. But there's got to be a way for my machine to be able to communicate with GitHub, or specifically for this .git directory living in my project to communicate with this repository. Well, this is called a remote origin. And let's make that arrow a little bit bigger just to make sure it doesn't get lost there. So that is called a remote origin. I want to set the remote origin of my project to be able to speak to this repository. How do I do that? I'm still at the project level with Git. I run Git status. You'll see that there's nothing on my working branch. If I run Git branch, we'll see that I'm currently on the main branch. This is exactly what I want. Now I'm going to run the command git remote -v. And this is going to tell me what origin I'm connected to remotely. Currently, it doesn't return anything. That's because I am not connected in any way to anything inside of GitHub. Now I want to become connected. It gives me this link in HTTPS. So I'm just going to copy that link there. Now, in order to add a remote branch, I'm going to pass in the command git remote add origin. I am going to add a remote origin to this .git directory. And I'm going to specify the link. So now I'm going to pass it. And now if I check it again, get remote -v, you can see that we have an origin to fetch and push information. And we're going to cover what fetch is here shortly. So now I can actually grab this entire project's commit history and pass it into my repository. So again, git status, there's nothing to change. Everything has been committed. Currently, my Avenger project is empty inside of GitHub. There's nothing there. But I know that in my machine, I have 2 directories with 2 separate files, 1 file inside of each directory. Well, now I need to send all of these .git directions over to GitHub. So that GitHub can utilize this .git directions in the repository to recreate my project inside of GitHub. So what I'm going to do is I'm going to git push origin main. So this git push should be what it means is I am pushing information into my repository. This origin is the alias that I'm utilizing here. These are my aliases. So by saying git push origin, I'm actually saying git push this information into https://github.com/favela0a/avenger project.get. But instead of writing that entire link, I'm just saying origin. So I'm saying git push origin, and then the branch that I want to push information to. Well, this is going to be the main branch. Now, in doing so, we see a couple of things add up there, all right, saying, hey, it's compressing files. It was able to write objects. Great. Resolving. Everything has been sent. A new branch was created inside of my project, of my repository that was labeled main. Well, now let's take a look here. I come back over to my repository. Nothing is there. But if I go ahead and send my request again and refresh my project, you'll see that now I have a client directory that if I took a look at main.js, it has my actual code that I've written of console.log say hello. I have my server, which has my function that I have written that will return some string for greeting Avenger. And it also has a record of all of my logs. I can take a look at my commits. And by taking a look at my commits, I can see that I have my complete functions, which was my merge. When I merge both main and my feature branch, I have my add a function to JavaScript, my refactor function, my add a function to Python, and my very initial commit, which was created 1 hour ago. All of my commits are present and live inside of GitHub. I can even look at their current state that they were there. If I go take a look at refactor Python, I can click on this code. I can see that if I look at my client, main.js is empty because at this point of history, we hadn't written any code yet inside of that JavaScript file. And my server, that was where I refactored my greet Avenger function in Python. All right, so now I have my entire project living inside of my GitHub repository. All right, see, we have some questions. Go ahead, Andy.
Yeah, I'm a little confused on the purpose of doing it on a local machine. If the version if I thought the version control was needed for to collaborate with other people. I'm just confused. Why would you go through this whole tedious process of I guess doing like commits and all this stuff, all this git stuff on your local machine, yeah, unless the end state is to eventually push it onto a database somewhere where everybody can share it. Like It's just not sitting in my head of what I in my head it's like you would create the project at a database somewhere and everybody would clone it and then you would work on it and not the other way.
Yeah, that's a great question. And I think you could go about it both ways. The way that you mentioned, where somebody would create a new repository and then send it out to everybody in the team and say, hey, this can be the repository that we're working with. Let's go ahead and start off this way. Right now, the issue with doing what you just mentioned is not necessarily an issue, but the conflicts that you may have is everybody may start the project differently, right? And if they go about creating the project differently, well, then how do you go about setting some sort of rhythm or system design patterns that everybody needs to follow, right? So the typical standard is someone or a team of people get into one room and they create it all inside of one machine. What is the template? What is the battle rhythm that we want to follow? What are specific texts that we want to make sure is being utilized and when it's going to be utilized? Once they have that one template, they send it up to GitHub and then they share it with everybody. And then from there, everybody has an initial step that they can take to create their own feature branches, make their information, and then send it back into the main branch. Does that answer your question, Andy?
Yeah, it kind of makes sense. If you're doing all like on this, and I think somebody mentioned like centralized. So you start off at one in one machine, but is it like how long would that the pro? I'm just trying to visualize in my head if I go and work with a team, and the project is a long-term thing. How long would it take for this layout to be established on that one local machine? If it's week, 2 weeks, then I can understand the Git process. But if it's like a short term thing, is that how it is? It's just depends on how long the process is.
It's definitely a depend by situation, but I would argue that it's always going to start that way. It starts Git locally, gets pushed into GitHub, and afterwards gets distributed into everybody. All right, awesome. Dallas?
I got three, I think, really simple questions. So, get remote add origin. That makes the URL, it establishes a connection to use with the repository that's on GitHub. Is that all that is?
Yes. Right.
Uh,
That's what tells Git, hey, this is where we're going to be pushing all of our information.
okay, so that's the pipeline, and then git push origin main. I think that's how you wrote it earlier. Was that pushes the information that you have on your Git to the GitHub that just uses your connection. That's right.
Mhm.
And then the last one is, and the 1 hour ago, Mark, was that for when you made it on your Git or when it was added to GitHub
That's when the last change was recorded on Git.
on Git?
So yeah, right
So
now,
I thought it was not on GitHub at all until just a minute ago.
right. So
Okay.
I made the changes on Git, and then GitHub is essentially just reflecting everything that happened inside of
Okay, I get it then.
it.
That's all.
All right. Any other questions? Okay. If there aren't any other questions, then let's go ahead and keep pushing forward here. Again, we were able to add a remote origin that was able to push information. We were able to push all this information here into this repository. And let me actually share this repository with everybody here as well. I'm going to go ahead and send it in the Avenger questions channel. All right. So the project now exists inside of GitHub, and I can view everything inside of GitHub as far as how to work with it. I can add files, I can manipulate files. We don't necessarily want to do any of our work in GitHub, but in the off, I'm doing this specifically for demonstrational purposes. I strongly don't recommend that you do any sort of quick actions inside of GitHub. Keep those within your local dev environment. So here, I'm going to go ahead and add a file. This file is just going to be my markdown file. I'm going to say, hey, this is going to be my readme.md. And here I'm going to go ahead and call this the Avenger intro to Git and GitHub. Currently learning about version control and managing Git and GitHub. All right. Then it's gonna ask me, hey, would you like to commit these changes? This is the same thing as doing git add and git commit. What I'm doing is I'm creating a README. So I create README. I'm going to commit this directly to my main branch. And there it is. Now I have a README file. But this README file doesn't exist inside of the local branch. Well, how do I get this README file back? I know that the current version that I have on my local machine no longer matches the current version of what's on GitHub. Now, I only know this because I changed it. If I was working with a team, what I typically like to do after I make a development branch and I'm done with my feature branch, I check out the main branch, pull the main branch so I can make sure that I have the latest version. Then I check out back into my feature branch and I merge again, right? Even if there's nothing to pull, always running that git pull command will always give you the latest information. And it's important that you just have that in your machine whenever you're working as a team. That's also part of the whole reason why we do these stand-ups and stand-downs, right? If you're working as a team, typically you do want to have some sort of meeting in the morning. You do want to have some sort of meeting in the evening. And if you do any meetings in the morning, that might be a perfect time to work together and say, hey, maybe we should all pull the latest version, see if we run into any sort of conflicts, and then we can manage that there and then to make sure that we have something to work with for the remaining of the day, right? So now here I'm going to go ahead and say git pull origin main. And in doing so, it tells me, all right, well, there's been one new origin, so we're going to move forward. We're going to create a README file, and we're going to insert 3 lines into it. And now if you take a look, I actually have a README file that has the information, Avenger intro to Git and GitHub, and currently learning Git, learning about version control and managing Git and GitHub. Right, so everything that's happening here is a forward and back communication. So now that we have a remote origin, I think somebody mentioned to, or somebody referred to it before as a pipeline. This pipeline goes back and forth, where we are able to push commits to repo. And we are able to pull commits from repo, right? All happening back and forth between our machine onto GitHub. All right. Well, where's the real benefit to this? Let's take a look here. As of now, everything was living inside of my machine. But let's say I'm a new member to the team. I'm going to come back here. I'm actually going to exit this out here. And what I'm going to do is I'm going to delete this entire project. So rm-rf, new project Avenger. All right, let's delete that entire project. If I run ls now, you'll see that new project Avenger doesn't exist. I'm gonna change directories into my desktop. And instead, this is where I want new project Avenger to live. So how do I bring this in? As of now, I know a couple of commands. I know that git add remote origin and then link is what creates the pipeline. I can spell between my project and my GitHub repository. I know that git push will push all of my current commits to GitHub. And then GitHub will utilize those commits to build my project within my repository. I also know that git pull will pull commits from GitHub repository. And this will, or it allows Git to create, let's do write or edit files within my local machine. Well, now I got rid of the entire project. So how do I get it back? We can go back to this Avenger project. And I'm going to go ahead and click on the Avenger project here. If I just wanted to clone this repository, I would simply click on the code. That would copy this URL to my clipboard. Now, by copying that URL to my clipboard, that will allow me to do the following. I can utilize Git to clone my repository. And now, inside of desktop, I will have my Avenger project. And if I open that up in VS Code, we can see that my Avenger project comes in exactly the same state that I left it. I still have my JavaScript file, my main.py file, and my README, just as we left it inside of GitHub. So let's add that to our notes here. We get clone, link, will clone, commit, or excuse me, we'll pull commit history from a repository and allow Git to create a project to create the project. There you go. That makes more sense. All right, so clone brings down that entire commit history and recreates the project inside of my local machine. Pretty similar as far as in functionality to git pull. The difference is git clone is more of, hey, this doesn't exist before. There was never a pipeline here that was established, right? So git clone will do all of the initial commands as well, making it something that I can work with. Now, what I mean by all of the initial commands, before I had to actually git add remote origin. But in this case, because I cloned, if I run git remote -v, it already has the origin placed inside of it because I cloned it down from GitHub. All right. Does anyone have any questions about that? Let's hear it, Dan.
Will we always use the alias origin?
It is standard to utilize the alias origin. If you utilize something different than origin, that will be determined by the development team that is currently working on it. But the standard as of common practice is always going to be origin.
Like,
Of course. Alex?
I see that there are two different links for fetch and push. Is there a common case where those links would be different, or is it usually just going to be pointing to the same GitHub repository?
They will usually be pointing to the same GitHub repository. Dallas?
Answered one of my questions, and for the fetch, is that just for the pull command? Is it
Yeah,
the same thing?
the fetch and pull, they're not exactly the same, but they do work very similar. You're going to be putting my GitHub and Git knowledge to the test if you're going to ask me the specific difference between the two. But they do function very similarly, bringing down and putting down.
But for the I guess the git clone link, which link did you use for that?
So here inside of my repository, I click on code, and then it brings up this HTTPS.
Which is the same one as the fetch and pull?
Yes.
Okay. All right, that's it.
All right, awesome. Any other questions? Okay, if there aren't any other questions, then let's go ahead and push this into a little bit more of a practical application. Let's make it a little bit challenging. Gary, do you have availability to jump into a little bit of a working with me to finish off the lecture? You are muted in Zoom. He's finding it, everybody. Or you are muted permanently. There you go.
Yeah, I had to go through my settings. What happened?
Do you want to work with me, contribute into working together on this GitHub repository?
Sure.
All right, awesome. So what Gary's going to do is he's going to clone down this project. And as he clones down this project, he's going to make his own feature branch. And I'm going to make my own as well. We're both going to have our own separate tasks. My tasks will be to add a separate function that just adds two numbers inside of this Python file. And Gary's task will be to create a function that adds two numbers inside of the JavaScript file. So let's say those two tickets come out, each one gets set to each developer, and now we have to tackle that down, all right? So again, just to clarify, Gary will create a function that adds two numbers to the JavaScript file. Meanwhile, I'll create a function that adds two numbers to the Python file inside of our own branches. So here, I'm going to go ahead and run git branch. I only have main because that's the only branch that was pushed and pulled. So now I'm going to go ahead and get checkout dash B. And I'm just going to do addition func. That's going to be my branch here. Now in this main.py file, I'm going to go ahead and create a function called add twos. It's going to take in two inputs. And it's going to return a number. Now I'm going to do is I'm going to return num1 plus num2. That's it. That's my entire function. I have my add twos here. Don't worry about this typing that I'm doing here. This is definitely optional. It's not something that you actually have to put inside of Python. It's a force of habit that I've gotten into. Actually, let me remove them to make sure that it's not causing any white noise. There you go. So there's my add twos. I'm passing num1 plus num2. That's it. That's the only thing I'm going to do here. If I run git status, I can see that only the server has been modified. I can add all of my changes and commit them and say create add twos function. Now I'm going to go into my branch again. I called it the add func. So I'm going to git push add func. And I forgot to add the origin there. All right, let's go back into my Avenger project here. So now my Avenger project exists. Well, we can see that there's an add func branch that has been created. How do I see that? If I go into my server and I go into main.py, nothing has changed. Well, currently I'm inside of the main branch. Instead, I want to see the add function branch. And the add function branch has my current changes and my latest commit. All right. So my portion of this project is done. Gary?
Yeah, I think I have to reconfigure my Git because of yesterday.
All right. Andy?
Yeah, I just had a question. When you push, did you just push the new branch? You didn't like you didn't you didn't merge it with the main one, right? Is that okay? All right.
Yes, that's correct. All right. Well, it looks like Gary's unavailable. So I'm going to go ahead and ask one of the other TAs, G1 or Charlie. Are either of you available to work out on this?
Yeah, sure.
All right, G1. Great. So
Uh,
actually, let me know once you have it cloned and you have VS Code open.
yeah.
Now pause the recording so this doesn't get placed into it. All right, so G1 has our project opened up. And just like I did, he's going to go ahead and create his own feature branch. All right, so he created a branch named G1 branch. So now he'll go ahead and check it out. All right, perfect. So now he has the G1 branch that has been checked out to. And now he's going to go ahead and accomplish his portion. He's going to create a function in JavaScript that will add two numbers. It will take two numbers as an input and return their addition or their sum. All right, perfect. So now he's done writing his function. He can go ahead and add and commit this, right? Because both of these need to be added and committed. It's git add. There you go. All right. So now he has created his commit, and then he's going to push his feature branch up to GitHub. Denied you want it will access. All right. Let me go ahead and pause the recording and then let me share it.
Oh, okay.
All right. So now the issue that we just saw was G Wong is not part of my project just yet. So I need to add him. I'm going to go ahead and come over to GitHub. Not going to need VS Code anymore at this point. And what I'm going to do is I'm going to go into settings. And instead of settings, I need to add a collaborator. So I can add people here. And then Ji Wong, do you mind telling me what your GitHub handle is again?
It's G1 Jung 414. So 10 JUNG
JUNG
and EONG
EO.
and 414. Yes, that one.
All right, perfect. So now G1 should receive an invite to being a collaborator.
Yep.
He'll go ahead and accept that on GitHub. And then once that's accepted, he'll be a collaborator. There it is. G1 is now a collaborator. So now he can push his feature branch. And he shouldn't have an error at this point. Let me know if that was successful, G1.
I think it's successful.
All right. So now we refresh.
Uh,
Not successful.
mm,
What are you getting?
I'm saying on branch G1 branch. Oh, I have to publish the branch. Yeah.
You should be able to do git push G1 branch. Git push origin
Yeah.
G1 branch.
Yeah, I think. It should be working.
All right, let's check it out now. All right, there it is. Now G1 branch is now available. I did see a hand populate. Was that a question?
Yes, originally I saw when he was typing in, he was pushing his main branch. If he were to push his main branch in there, would it override your main branch currently in there? Or would
No.
it add a pull request?
If he were to strictly push into the main branch and he had a different commit history, then yes, it would override the main branch. Right? At this point, it doesn't just belong to me, it belongs to both of us. So it's important for both of us to be super careful. That's why the first thing that we did was switch to a feature branch. Even if we're on a feature branch and we do the command of git push origin main's actual git history never changed. So it wouldn't push anything. It would just say, oh, your working tree is clean. There's nothing to push or there's nothing to commit, right? Whereas his feature branch, once you push his feature branch, then it gave him that success message and actually sent it. Does that answer
All
your
right, thank
question?
you.
Okay.
Yes.
All right, Dallas.
For the since you added G1 to it as a collaborator, was there a setting in there that you could have made to make it so he can't push a main branch up, but only I forgot the term for the branches.
There is. So those are called protection rules. You can click on branches here and you can add a branch rule set. By adding a branch rule set, you can protect your most important branch. Yeah, so you can here you can say, hey, what I want to do is protect main. There shouldn't be a bypass, so we don't necessarily have to worry about that portion. Um, so the bypass list can stay empty. Main is just my default branch, so I can just say default. And then I could restrict your deletions, restrict creations, et cetera, et cetera. And then I would create the rule set to actually be able to protect that main branch. Does that answer your
Gotcha.
question?
Yes, sir.
All right. Now let's go into this code here. Oh, yes. Leave. All right. So I have my function or my branch. And here on this branch process, I made a change and I want to create a pull request. Create two functions. Made changes to main.py. Please approve if function is up to par. And I'll go ahead and add a reviewer there. G1 is my collaborator, so he has been requested to be my reviewer. And I can finally create my pull request. So my pull request is created. And at this point, it gives me the option to merge it if I wanted to. This would merge into main once I go ahead and click this button. But instead, I'm going to wait. I'm going to wait, and eventually G1 is going to approve my pull request. So currently it says pending review, so I'm still waiting on it. All right, so it is. G1 has just made a new change to it. We can say, hey, approve these changes, and he sent me the looks good to me. All right, awesome. So now at this point, I've gotten an approval, so I can go ahead and merge my request. I can confirm my merge. And now it tells me, hey, you have committed the add function branch to main. And then while I demonstrate that this was successful, can you create a pull request as well, G1, and add me as a reviewer? All right. So now I'll go over to my server, click on main.py, and there you can see that in the main branch, add twos has been added. Well, now the same thing is going to happen vice versa, right? Now G1 is going to create a pull request. So I come over to pull request. Currently, there's none open just yet. Give it a couple more seconds here. All right, there it is. So G1 has added me. I'm going to go ahead and look at this. You put first commit. He's requesting something. Well, I'm getting this commit message, but I want to see what exactly is it that he changed. So I'm going to look at the commits there. It looks like there's one of them. I want to look at the code base. What did G1 change? Well, if I take a look at the client and main.js, tells me this is what he changed. He added those add twos. What else can we do here? Let's see. If I come over here and I just simply click on the hash, instead of having to look at the entire code base, I can click on the commit message itself or the hash itself, and it would show me, hey, the difference is that instead of just ending at 3 lines, we have a continuation of this file that came all the way down to add twos. And I can review changes. I can say, hey, this looks great. Maybe I can make recommendations and I could leave it as a comment if I wanted that. If I wanted to request changes, I could also click, hey, I want you to actually fix this before I approve it. But in this case, I'm going to go ahead and approve it and submit my review. So now that it's approved, G1 would get a message saying that this is good to go. And then he himself could go ahead and merge his pull request when ready. I can go take a look at the code. We can see that G1 has now merged his pull request. Can take a look at client, main.js, and now both of our functions have been integrated into our project, working from 2 completely different machines, but working off of 1 local repository. All right. At this point, does anyone have any questions over Git or GitHub? Let's hear it.
So which one was the latest change? Was G1's the one that was kept on the main, or I'm not? You didn't merge it with main yet. You just approved his branch code. Is that what it is?
So I approved his branch code, but he merged it with main. So
He
both,
merged with your branch?
yes, both of our branches are back in main now, right?
Okay, so I was wondering, did he overwrite your code in the main?
No, he did not. And the reason why he didn't overwrite my code is because all of his code that he wrote was in a completely different file than the code that I wrote. So when we merged together, or we merged, our code was compatible. It didn't overwrite one another. If we had worked inside of the same file and written code that was overlapping on top of one another, then it would have created a merge conflict and it would have opened up that portal that we had talked about or told me that I needed to do it locally.
Oh, so he did server and you did client or vice versa. That's what happened.
Correct.
Oh,
Awesome. All right, Chase.
Hey, so when you clone something from a repo, you only get the main branch, and so like what if there was a case where you wanted all the different branches on the repo? Could you clone them all? I don't know if that makes sense.
I'm not sure if there's a command to clone them all at once, but I can do get pull origin or get pull G1 branch.
Oh, okay. So you just pull whatever branch you want individually to your system.
Yeah, let me go ahead
Okay.
and here. I don't remember the command is on top of my head, but I know that's how it works. Did I misspell that G1 or did I spell it correctly?
I think we since we merged it, it's gone now. That's what I'm thinking.
No,
It's
it's the branch. Um,
Do you have permission to pull his branch?
I do, yes. Let me see here.
Sorry, I got distracted by a kid. What's happening right now?
I am trying to pull G1's branch, but I
can
can't.
you just get checkout my branch?
I think it is. Let me go ahead and do that. Nope, it's not. See, so it tells me.
Do you have to say origin?
Oh, that might do the trick. Yep, that's what did the trick. Thank you. So now if I do get branch, oh, excuse me, yeah, check out G1. Now it's able to switch it. And if I run get branch, it'll show me all three branches. There
Great,
you go.
thanks.
Of course. All right. Sorry about that, everyone. Dallas?
Can you explain why the origin had to be there? Was it just another directory down, or what?
Yeah. So the reason why origin had to be there, right? I was saying get pull, but I was never telling it where to pull from. I was just saying, hey, there's something G1 branch that I want you to pull. But I was saying, okay, where am I supposed to find this? Right? When I set that remote, that's what gives me the alias origin. So again, it was my mistake, right? I was giving it a have command. I was saying get pull something called G1 branch, but I wasn't telling it where it existed. So by adding origin, I was saying, hey, go look inside of this GitHub repository, find G1 branch and pull it in. And that's what
Then without origin, does that mean that you were checking just all of GitHub, or because of your alias there assigned?
it was just crashing because it didn't know, it didn't have a way to interpret that G1 branch text to an HTTPS link. Right? And that's what that get pull expects. It's expect get pull and then some sort of link to a GitHub repository. So because I
Oh, okay,
that it was crashing and letting me know that there was a problem with the path.
gotcha.
All right, Andy.
I saw that when you did git pull G1 branch and then you did git branch, it didn't list the G1's branch until you checked out. Is that just how it works or?
Unfortunately, that's just one of the problems with Git. When it's happening locally, it won't be tracking the existence of the new branch until you check it out. Alex?
So if you just run git pull, will that just pull from main then, according to the origin that you have set up, or would it also pull from the branches that it knows exists,
If
like on your local Git repository as well?
you would have to set up an upstream to just be able to run git pull and not specify where to pull from. Otherwise, it's always going to want you to explain the origin and which branch. So for example, if I were to conduct a pull now, I would have to say git pull origin and then main. And then it would pull the information.
So git pull by itself does nothing really,
Unless I
unless you have it set up beforehand. Okay.
all right. Any other questions? Okay, perfect. Thank you so much, everyone. Let me go ahead and stop our recording here.